Yeah, what's up, guys? So this is another video about this Merlin protocol. And basically, the simple implication is that what if graph isomorphism is NP complete? Also, the standard, as I said, right, the golden rule in the computer's complexity theory is that pH never collapses. So never collapses. Okay. As I said, right, the common. If you want to prove that something, is unlikely to happen, then the standard proving strategy is that assume something is true, and then you show that the pH collapses. Okay. And then you can, by contradiction, say that if pH never collapses, then something is unlikely to happen. Okay, the simplest one will be P equals to NP, which implies that the pH collapses into P. And another one which is also famous in the quantum computing or whatever, right? So if it turns out factoring to be NP complete, since factoring is both NP and co-NP, right? So then NP will be co-NP. Okay, then the factoring and the pH will collapse into the first level. And also another one is that we proved in the previous video that if you assume that added randomness will help you to solve the P problem, then this will always also prove that sigma 2 is the same as pi 2. Okay, and there are more and more results. Okay, and now the famous results is that today I want to prove basically it's the graph isomorphism. So people know that somebody give you two graph, right? If graphs are accessible, how about graph isomorphism is a B complete? Is this possible? Okay, so we will show that if graph isomorphism is a B complete, then also pH collapse into the second level. Okay. So proof idea is very simple, right? So the idea is very simple, right? So let's say this is GI. Right, so if GI is B complete, then this implies that the graph non-isomorphism is co-NP. Okay, but graph non-isomorphism is in so every co-NP problem can be solved by G and I, right? So this means that G and I is in AM, right? Because by definition, so G and I is in AM, right? And every co-NP problem can be reduced to G and I graph non-isomorphism, which proves that the co-NP is a subset of AM. Okay. And then you just write down the definition, right? So this means that x belongs to L, right? So therefore all P, some point, some length or input, then the verifier will say 1 is a subset of AM, right? So AM means for most of the random bit that Arthur sent to Merlin, and the Merlin give a message is this, right? So simply speaking, that you can replace this for all into this for most and exist. Okay, but this will collapse the hierarchy. Okay, because in the sigma 2, right? Sigma 2 you can write exist for all P. But now you can replace this for all, right? So you can replace this for all P replace this co-NP part into our results, right? Into our previous results. So it's for most exist P. Okay, so it's using the co-NP as a subset of A. Okay, so from here that you will need another result. So basically, this one can say that there exists a message that Merlin can send to Arthur, and Arthur reply random bit, and Merlin say something, and Arthur accept. Okay, so this means that sigma 2 is basically in the Merlin, Arthur, Merlin. Okay, right. So sigma 2 is a subset of MAM. Okay, and the fact is that as we proved previously, so MAM, everything higher than AM is AM. Okay, so it's A. Okay, but as we proved previous video that AM is in pi 2, right? So this proves that sigma 2 is in pi 2, right? But sigma 2 and pi 2 are both complement to each other. So if you complement, you get pi 2 in sigma 2. So this proves that pi 2 equals to sigma 2. Okay, and the pH collapses. Okay, so this give you something. This proves that graph isomorphism, if graph isomorphism is complete, then something. Okay, so this actually proves that A colon P is unlikely in subset of AM, right? Colon P is unlikely in subset of AM. If colon P is a subset of AM, then this implies that this will have all these consequences. Okay, so one fact, so another comma theorem is that say that if colon P is a subset of AM, and the polynomial hierarchy will collapse into the second level. See you guys next videos.